Hi everyone. Today I'm going to talk about the nomenclature of variable charge ionic compounds. So those are ionic compounds, a metal plus a nonmetal, where the metal has more than one possible charge, and we're going to have to determine what the charge is. Okay? If you have not watched my video on the nomenclature of non-variable charge metals, I strongly suggest that you go do that before you watch this video because it kind of leads you into it and it'll make this video so much easier. Okay, so let's get started. Okay, so first let's remind ourselves which metals have variable charges. Okay, so they are the ones that are outlined in red here. Okay, remember that, here I'm going to change my color. Remember that these guys are all +3. I think in my last video, I said that the thallium was +3 also. I was wrong about that. I will correct that in that video. Zinc and cadmium are always +2 and silver is always +1. Okay, so those are not variable charges. Okay, the ones that I have with the green slashes through them, those are your metalloids or your semi-metals. They're kind of like metals, they're kind of not like metals. You might get those in an ionic compound. If so, assume they're variable charge and just do them like the other metals, like the other variable charge metals. Okay. And technically, all of these down here, the F block, are also variable charge, but I seriously doubt you're going to have any of those in your nomenclature. If you do them just like all of these other variable metals. Okay? Okay, so these are the same exact three rules. Well, okay, so we had two rules for the non-variable charge metals. Okay, we had three rules, but the thing is this right here. This is where we're going to determine the charge on the metal, okay? On the non-variable charge metals, we just go to the periodic table. Group 1 is +1, group 2 is +2, group 3 is +3, okay? But now these are all in those variable charge area in the transition metals. So we have to know what the charge is. Well, if you're given the name, your charge is right there in the name in Roman numerals. Okay, so real quick, let's just do our Roman numerals real quick. 2, 3. Okay, 1, 2, and 3 are pretty easy. 1 slash, 2 slash, 3 slashes. Okay, 5 is a V, and 4 is V minus 1. The 1 goes in front of the V. So 4 is V minus 1. Okay, so 6 is V plus 1. 7 is V plus 2. 8 is V plus 3. Not 10, sorry, we'll go 10 first. 10 is X, and 9 is 10 minus 1, the one in front of the 10. Okay, so the 4 and 10 have the same rule. 5 minus 1 is 4, X minus 1 is 10. Okay, so those are your Roman numerals. I know a lot of people have not worked with Roman numerals a lot, so there they are. Okay, so we are going to write the formula for our cation and our anion. So manganese is Mn because the N came first in the name. And sulfite, we know from supper in our Nick the Camel saying that sulfate has 4 oxygens. So sulfite has 1 less, sulfite has 3 oxygens. Okay, now we're going to determine what the charges are on each of those. Okay, we know sulfite is -2. Okay, that's a given. We've known that from memorizing sulfite. Also from the supper, it has 2 vowels in it, a 2 negative charge. Okay, manganese, our charge is right here in our name. Manganese is a +3. Okay, so we got our charges. Now we're just going to swap, drop, and reduce. The reduce is if necessary. You won't always need to reduce. Okay, so I'm going to swap. My manganese gets a 2 and my sulfite gets a 3. So the manganese gets a 2 and the sulfite, got to put that in parentheses because it's a polyatomic, it gets the 2. Okay, so now we have lead. Lead is Pb because plumbers use lead pipes. Okay. Oxalate is one of your memorizers. He's C2O4. Okay, now we look at those charges on there. Our name right here told us that the lead is +4. You've memorized that oxalate is -2. Okay, so when we swap those, the lead gets a 2 and the oxalate gets a 4. Okay, but look, those are both divisible by 2, so you have to divide them by 2. So I get 1 lead and 2 oxalates. Okay, so 1 lead, 2 oxalates, have to put it in parentheses because it's a polyatomic. Okay. Okay, so now I have 10,2-selenate. So 10 is SN. Selenate is right, selenium is right under sulfur on the periodic table. So it follows the same rules as sulfur does. So it's got 4 oxygens and a -2. So selenate is, whoops, it's 4 oxygens and a -2. So we know he's a -2. And the 10,4, or 10,2, sorry, the 10 here is a +2. So when we swap and drop, those each get a 2, but they're the same. They already cancel each other out, right? So they already negate each other. If we swapped them, we would put a 2 and a 2, but then you'd have to divide them both by 2 and get a 1 and a 1. So you just leave them like they are. If your charges are the same negative as the same positive, you don't need to drop, you don't need to drop them. You can just cancel them out. It's just one of each. Okay. Okay, so now I've got iron 2 chromate. So iron is Fe. And chromate is the one that has only 1 chromium. Remember, dichromate has 2 chromiums. So 1 chromium, and if you're 1 chromium, you're 4 oxygens. Our name here told us that iron is a +2, and chromate we know is a -2. So again, they already cancel each other out. We just need one of each. Okay, now I've got chromium, which is Cr, hypoiodite. Okay, so remember iodine is a halogen, just like chlorine. So from clam on our periodic table, we know iodate has 3 oxygens, iodite has 2, hypoiodite has 1. So hypoiodite is just IO. Our name told us that the chromium is a +3. We know our halogens are a -1. So we're going to swap and drop. We got a 1 to the chromium and 3 to the iodate. So I need 3 iodates, but I can't just do that because that's telling me, I'm sorry, iodites. So that's telling me I have iodate. You have to put parentheses around that to make it the hypoiodite, 3 of them. Okay, so remember, multiples of polyatomics, you got to put parentheses around them. I spelled this wrong. Spelling matters. Molybdenum. There should be. Is there an? Hold on. Molybdenum. Nope, it does not have an E in the middle there. I did spell that right. Okay, molybdenum. Okay, so. Okay, I was just making sure that's a U and not an I. Okay, so molybdenum, the formula for molybdenum is, by the way, in case you're curious, he's 42 on the periodic table. He's MO. Phosphate from Phoenix in our Nick the Camel saying has 4 oxygens and a -3. So 4 oxygens, and we know he's a -3. And the molybdenum told us that it's a +7. So I'm going to swap and drop those. The molybdenum gets a 3, phosphate gets a 7. So I need 3 molybdenums and 7 phosphates. Okay, and make sure this O on the molybdenum, that's a lowercase o, that it doesn't look like the O in the phosphate. Okay. So now I've got cobalt fluoride. So cobalt is CO. Fluoride, remember if it ends in ide, it's just a monoatomic ion, so just F, no oxygens. And our name told us that the cobalt is a +2. Fluoride is a -1. Okay, so I'm going to swap and drop those. 1 cobalt, 2 fluorides. So I need 2 fluorides on that. Okay, so copper 1 nitrate. We know copper is Cu, like you're speeding away, Cu copper. Okay, nitrate, we know from Nick in the Nick the Camel saying that nitrate has 3 oxygens and 1 negative. So 3 oxygens. He's got a 1 negative. And copper here, our name told us that he's 1 positive. It's 1 and 1. They already cancel each other out. We're done. Okay, now we have another copper nitrate. So same formulas, Cu copper, NO3 for nitrate. Okay, our name told us now this is copper 2. Our nitrate's still a -1. So I bring my 1 down there to my copper and 2 to my nitrate. So I need 2 nitrates. Put it in parentheses because there's multiples. Here you'll see I did not put that nitrate in parentheses because there's not multiples of it. It's only when you have multiples of a polyatomic that you have to put it in parentheses. And I apparently did not finish writing this formula. So let's go. Let's go chlorite. Okay, so tungsten, and the reason I did this one is because a lot of times your instructors will throw that on you and you'll search for a T on the periodic table. Okay, tungsten on the periodic table is W. Okay, he's a W. Okay, and chlorite, we know chlorate from clam has 3 oxygens and a -1. So chlorite, 1 less oxygen, so 2 oxygens. He's a -1. Our name on tungsten told us we're a +3. Swap and drop 3 chlorites, 1 tungsten. So I'm going to have to put that in parentheses to give me 3 chlorites. Okay, so that is name to formula. Your name will always tell you what your charge is. You're following the exact same rules that we followed with non-variable charge metals. Okay, write your formulas, determine what the charges are, swap, drop, and reduce if necessary. Okay, now we're going to go the other direction. We're going to go from formula to name. Okay, so if you were working along with me at home and you have this written on paper, cover up all of your formulas, okay, or cover up all of your names, and now we're going to write the name that goes with that formula. So cover up your names and do it on another piece of paper. Okay, so our first rule is we write the name of the metal, which is your cation. Okay, so Mn is manganese. Okay, we put parentheses because these are variable charge metals. We're going to have to put the Roman numeral in parentheses. So I do my parentheses, then I name my anion. Okay, so SO3, we know from supper in our saying that sulfate has 4 oxygens. So SO3 is sulfite. Okay, now we're going to determine what the charge on the metal is. Okay, and we're going to do the opposite of what we were doing earlier. We're doing swap, drop, and reduce. Reducing is dividing. Now we're going to swap, raise, and multiply if necessary. Okay, so I have manganese sulfite. Okay, and if we do the swap, we're going to swap. So remember when we swapped and dropped, we dropped the charge down to the subscript. Now we're going to take the subscript and raise it up to the charge. Okay, and there's something that we need to check. We need to check if true. And if it's not true, that is when it's necessary to do a multiplication. Okay, so we're going to swap and bring the 2 up. So we're saying that the sulfite is a -2. And that is true. Sulfite is a -2. Oh, I had something wrong there. This should have been a 3. Sorry about that. That was a 3. Okay. So now if I swap my 3 up, that means manganese is a +3. Since this -2 was true, my +3 is true. So that's manganese 3 sulfite. Okay. Pb is lead because plumbers use lead pipes. Lead, I put my parentheses, write the name of my anion. C2O4 is the oxalate that you had to memorize. Okay, and now we're going to do a swap. So I swap this up here, and I am saying that that is -1. That is not true. Okay, so I'm going to come down here, write that again. Okay, so when I swap, I say that's -1. That is not true. Okay, we know oxalate is -2. So you know it's -2. So you have to multiply that -1 times 2 to get your -2. Well, we brought that 2 up. So if we multiplied to make the anion true, we have to multiply to make the cation true. So I have to multiply that by 2, so that is lead 4. Okay, so I've got lead 4. Okay, so right now I'm going to show you the mathematical way to do it that will always be right as long as you do your math right and you know your charges. Okay, it's a little bit more difficult, so the swap, raise, and multiply might be easier for you. But the real way to do it, okay, is we know, okay, so we're going to look at the charge on the ion times the number of that ion is going to give me my total charge. Okay, well, we always know our anion, okay? So we know our anion is -2. Oxalate is a -2. There are 2 of them there. So I have a total -4 charge. Okay, so over here, I need a +4 charge. My oxalates, oh, I was just doing my oxalate, sorry. I need a +4 charge. I have, so I'm looking for my charge. I have 1 lead and I need a +4. So if we divide by the 1, we know that that has to be lead 4. Same thing that we got up here. Okay, so you look at your anion, the charge on the anion times the total of number of ions that are there gives you your total negative charge. Now you need that total positive charge to make it all equal 0. So here you're looking for your charge. Here you're determining your charge. Okay, because you already know your charge and your number of ion. Here you know the charge you need and your number of ion. Okay, so it's totally up to you. Let's do that manganese one that I had a minute ago. So the Mn2SO3, Mn2SO3, 3. Okay, so here I know that sulfite is a -2. I have 3 of them, so I have a -6. I need a +6. I have 2 manganeses. I need to know what that charge is. So I divide by the 2. It's +3, just like we said he was up there. Okay? So the rest of these I'm going to do with the swap, raise, and multiply. Okay, so here we had said this is not true. So we have to multiply by 2 to make it true. So we brought that 2 up. I need to multiply it by 2 to make it true also. So that is lead 4. Okay, Sn is 10, parentheses for the charge. SeO4, Se is right underneath sulfur on the periodic table. So we know from supper, sulfate has 4 oxygens and a -2. So selenate also has 4 oxygens and a -2. So that's selenate. Okay, now I need to figure out what my charge is. Okay, I'm going to move down here. SnSeO4. Okay, so when I do my swap, what you need to recognize is that's a polyatomic ion. There is only 1 of them. I bring a 1 up here, and I bring a 1 up here. Okay, don't bring that 4 up. That 4 is not the number. That is 1 of that ion. 1 ion, okay? Well, this is not true. -1 is not true for selenate. Selenate is a -2. So I need to multiply him by 2 to get my -2. So I need to multiply him by 2 and get a +2. Okay, so that is 10(2) selenate. Okay. Fe is iron, parentheses. CrO4, I have 1 chromium, so that's just chromate. Remember, dichromate has 2 chromiums and more oxygens. Okay, so now I'm going to determine what the charge is on that. I'm going to come down here. Well, no, I'm going to just do it up here. Okay, so here, remember that is 1 chromate. So if I bring my 1 up, I'm saying +1, and my 1, I'm saying -1. Well, chromate is a -2, so that's not true. Okay, so we're going to have to multiply it by 2 to make it true. So I have to multiply that by 2 to make it true. So that's iron 2 chromate. Okay. Now I've got Cr is chromium. IO, so remember iodine is a halogen, and we know from clam iodate has 3 oxygens, iodite has 2, hypoiodite has 1. So that is hypoiodite. Okay, and if we swap, I bring my 1 up here, -1, that's true. Okay, all of your halogens are -1. So I bring my 3 up. That means chromium is the +3. Okay. Here I've got MO is molybdenum, molybdenum with a U, parentheses for his charge. PO4, we know from Phoenix in the Seine. Phosphate has 4 oxygens and a -3, so that's phosphate. Okay, if we bring this up, we're saying that's -3. That's true. Phosphate is a -3. So we bring that up, making molybdenum the +7. And that is true. Okay. CO, I have cobalt, parentheses for his charge. F is fluoride. Remember, monoatomic ions always end in "ide." So that's fluoride. And remember, just because there's 2 of them there, it's still monoatomic ion. It's just one type of element in that ion. It's monoatomic. Even though there's 2 there, that's due to charges. Okay. So now I swap. So I bring my 1 up, and it's true. Fluoride is a halogen, so it is -1. That's true, meaning the cobalt is a +2. Okay, here I have copper, Cu copper, parentheses for his charge. NO3, we know from Nick in the Seine that nitrate has 3 oxygens and a -1, so that is nitrate. Okay, if I swap, I bring my 1 up, saying nitrate's a -1. That is true. Okay, remember that 3 is part of nitrate, so you're just bringing a 1 up. So copper is a +1. Okay, I have copper and nitrate again. Okay, if I swap, my copper says -1 for the nitrate. That is true. So if I bring my 2 up, that means since nitrate is -1 and it's true, copper is +2. Okay, so see, those are 2 very, very different chemicals. This is why we have to put the charge in. Is if I were mixing those chemicals for a lab to run and I used copper 1 instead of copper 2, it would not do the reaction that you need for it to do. So those are 2 very different chemicals, and that is why we have to put the charge in the name so we know which one we're working with. Okay, so now I've got W. Remember, that's our tungsten, parentheses for his charge. And we know from clam that chlorate has 3 oxygens and a -1. So 2 oxygens, 1 less, that's chlorite. Okay, now we're going to do the swap, and we say chlorite is a -1, and that's true. Chlorite is a -1. So we bring the 3 up to the tungsten. So the tungsten is 3. Okay. So that's how you go from formula to name, okay? When we went from name to formula, we swapped, dropped, and reduced. When we're going from formula to name, or formula to name, right? We're doing the opposite. We're instead of swapping and dropping and reducing, we're swapping and raising and multiplying. Okay, so I have one more quick thing to talk about with these. Okay, and that is the Latin names. And some of your instructors will make you know these and some of them won't. Okay, when you're using Latin names for your cations, for your metals, it's only when they have variable charges. Okay, the rule is the higher charge ends in ic. Okay, don't get this confused with the acids. There are ic acids. This is when we're looking at just the metal, the cation. Okay, the lower charge is us, which is just like those acids. Okay. And I just remember ic is higher than us. I comes before the O in the alphabet. I is first. So ic is higher than us. Okay. So for example, if you had where I had that copper, when I had copper 1 nitrate and copper 2 nitrate. Okay, copper 1 is the lower charge. That would be cuprous nitrate. And copper 2 is the higher charge. That would be cupric nitrate. Okay, if I had lead 4 and lead 2, okay, the Latin name for that is plumb, right? PB, because plumbers use lead pipes. The higher one is plumbic, and this is plumbus. Okay, SN 10-4 and 10-2. Stan is the Latin name for tin, Tin. So that's the higher one is stannic. This is stannous. Okay, I'm going to talk about a weird ion. I've got mercury 2 and mercury 1. Okay, mercury 1, this is mercury 1. And this is mercury 2. Okay, what you'll notice is they both have a positive 2 here. Okay, but here's 2 of them. What it is mercury 1 never hangs out alone. He always hooks up with another mercury. So it's 2 mercuries with a total positive 2. So if you see a 2 here, that's mercury 1. If you see a 1 here, that's mercury 2. Okay, well, my higher charge, this would be mercuric, and this would be mercurous. Okay, so if you're looking at Latin names, these would be ones that if your instructor has you memorize the charges on them, and a lot of times you will have to memorize that copper is a 1 or a 2, lead is a 2 or a 4, tin is a 2 or a 4, mercury is a 1 or a 2. Okay, so that's how you know with the Latin names what the charge of the 2 possible charges is the ic is the higher of the 2 charges. Okay, so that is doing the nomenclature of variable charge metals in ionic compounds. That's all I have to say about that. Have a great day.